Welcome back to Trend Guards, where we cut through the industry hype to bring you verified, fact-based tech analysis. Today, we're digging into Apple's August 25th, 2026 hardware announcements. We're going to break down exactly what's going on with their new silicon and why it represents a massive shift for AI workloads.
Right off the bat, let's lead with the most crucial, confirmed fact of this entire release. Apple has officially dropped its first 2nm processor, built by TSMC. This is a massive manufacturing milestone, and honestly, it dictates everything else we're going to talk about today.
So, on August 25th, 2026, Apple officially unveiled two new pieces of silicon, the M6 and the M5 Ultra. In this explainer, we're going to completely separate the official hardware specs from the industry noise and look at exactly what these chips can do based solely on the confirmed evidence. According to Apple's official documentation, the base M6 features a larger 12-core CPU and a 12-core GPU. But here is the architectural detail you really need to pay attention to. Apple has actually integrated a neural accelerator into every single GPU core. It also packs a dual 16-core neural engine, and it supports up to 170 gigabytes per second of memory bandwidth. To put that into perspective, that's 2.5 times the bandwidth of the original M1 chip.
And that brings us to why this specific architectural change matters so much. Apple claims that putting a neural accelerator into every GPU core gives them a 30% AI performance boost per core compared to the previous M5 generation. It's a highly targeted, measurable upgrade specifically for on-device AI compute.
When we look at the exact pricing data, we see a very clear strategic pivot from Apple. The previous generation Mac Minis usually started between $499 and $599. But the new M6 Mac Mini starts at $899. Now, before you balk at that price, that base model now includes 16 gigabytes of standard unified memory. This pricing shift tells us Apple is totally repositioning this machine. It's no longer just a budget consumer desktop, they're turning it into an entry-level AI home lab workstation.
And you know, the technical community sees this pivot perfectly. A verified commenter over at 9to5Mac really hit the nail on the head, saying, "All these AI home labbers are about to have a field day. Apple knew what they were doing on this." That is exactly the target audience here, developers who desperately need local inference without constantly relying on the cloud. Let's strip away all the marketing language and just look at the official facts for the new Mac Studio. The M5 Ultra uses a quad-die architecture, scaling all the way up to a 36-core CPU and an 80-core GPU. But honestly, the most crucial confirmed metric here is the memory limit. This chip supports up to a staggering 512 gigabytes of unified memory, and it's running at 1.2 terabytes per second of bandwidth. So how do they actually achieve that kind of scale? Well, it comes down to their Ultra Fusion technology. As documented by both Apple and Gizmodo, this proprietary architecture fuses 4 separate silicon dies into a single, unified system on chip. This is the exact technical mechanism that allows that massive 512 gigabytes of memory to be shared seamlessly across the entire system.
We know the specs, but why is Apple betting so heavily on local compute right now? It comes down to 3 verified business advantages. First up is privacy. Running models right there on your desk means your data literally never leaves the device. That's a strict compliance requirement in sectors like healthcare and finance. Second is latency. Local inference is pretty much instant, which enables real-time agentic workflows, meaning the AI can act autonomously without network delays. And third, cost. Buying a Mac Studio is a one-time capital expenditure, which is often far more economical in the long run than the recurring operational expense of renting cloud GPUs month after month.
According to Apple developer documentation and recent reporting from Bloomberg, the software and hardware are now officially in place for Macs to rival dedicated servers. With macOS Tahoe 26.2 and Apple's MLX machine learning framework, developers can enable distributed inference across multiple Macs. By daisy-chaining them via Thunderbolt 5, they can share data at 80 gigabits per second. You are effectively building your own local AI cluster.
If we impartially compare Apple's ecosystem to the broader market, there are some very distinct trade-offs. Apple Silicon gives you highly integrated memory-bound advantages that are incredibly energy efficient. Cloud GPUs, on the other hand, offer immense scalable power, but you're renting them, and your proprietary data has to leave your premises. Then you have NVIDIA workstations. These are immensely powerful, dedicated GPU servers, but they're complex to manage and can easily set you back upwards of $50,000. Apple is really carving out a unique middle ground here, completely focused on unified memory capacity.
So, to synthesize all the source material we've analyzed today, here is the confirmed, actionable playbook for developers. You can run local inference for highly sensitive workloads to guarantee privacy. You can build Thunderbolt 5 clusters capable of running massive 400 billion parameter models. You can fine-tune your models locally using that 512 gigabytes of RAM. And you can prototype efficiently on a Mac before pushing your scaled-up workloads to the cloud. Apple has clearly laid out their vision for on-device compute, but based on the facts, the specs, and the pricing we've broken down today, you've got to weigh the evidence for your own workflows. What makes the most sense for your next deployment? A local AI workstation or a cloud GPU? Let us know what you think. Thanks for joining us for this Trend Guards Explainer. Stay focused and keep learning.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.